In this quick demonstration, I'll show you how to evaluate angles using sine and the unit circle. This is part 1 of the series. What you'll need to be successful in this tutorial are the following facts. You'll need to know the trigonometric functions sine, cosine, and tangent and their ratios. And you also need to know two special triangles, namely the one that you see here and this one, and of course the radian version of these triangles. For example, 60 degrees would be pi over 3, and 30 degrees would be pi over 6. So let's start with question number 1. In question number 1, they are asking us to evaluate sine for the angle 25 pi over 3. Now, we need to find out where this will lie, where it will end up with. And there are 4 quadrants. Let's take, for example, this unit circle. This is quadrant 1, 2, 3, and 4. And normally all cosine ratios are positive here. Every trigonometric ratio is positive there. Only sine is positive here, and only tangent is positive here. So that's something else to keep in mind as well. So how do we find out how much 25 pi over 3 is? The best way to do this, and we know that this number is greater, a lot greater than 2 pi, which is 1 round. So to find out how many times it will spin, what you'll need to do is take this number and divide it by 2 pi. The angle 25 pi over 3 divided by 2 pi, and this will tell us exactly how many spins we'll need. We're going to take the reciprocal of this number and change this symbol to multiply. 25 pi over 3 times 1 over 2 pi. Notice that this right here is the reciprocal of that. If we multiply this out, we end up with 25 pi over 6 pi. Now these pi's will cancel out, and we're going to divide 25 by 6. 25 by 6 is 4 and a little bit. So this means it will take 4 spins. 1, 2, 3, and then 4, and a little bit. So it's going to be in this quadrant. It's going to be in this all positive quadrant, the first one. Now to find out how much exactly that little bit that we excluded in this number is equal to, what we can do is take this number 25 pi over 3 and subtract it by 8 pi. Now you're probably curious as to why I picked 8 pi. Well, think about it. One complete spin is 2 pi. And if you multiply it by 4, you end up with 8 pi. So by subtracting this number by 8 pi, you'll see what the rest is equal to. So let's do that. If we subtract these two numbers together, I'm going to put a 1 underneath here. I'm going to find a common denominator, so I'm going to multiply this and this by 3. And I end up with 25 pi over 3 minus 24 pi over 3. Now I can easily subtract the tops, and I end up with pi over 3. So that angle that represents this larger angle is pi over 3. Next, what we will do is represent this on a Cartesian plane. And this terminal arm represents pi over 3. That's the angle that represents this arm right here. And if we make this into a 90-degree angle, and we fill in this angle and this one right here is pi over 2, which represents 90 degrees. And this one right here is pi over 6. Now, if you recall at the beginning of this video, I said it's best to memorize the special triangles. And if you did, that's great. Because if you had memorized those triangles, you would notice that this right here is the square root of 3, and across would be 1, and this over here would be 2. Now, we had sine of pi over 3. That's what we discovered, which is equivalent to 25 pi over 3. Sine is opposite over hypotenuse. And so therefore we have 3 square rooted and 2 as our denominator. And that right there is the final answer to this question. Let's try another question that's similar to the one that we just did. So this time we have evaluate sine 49 pi over 6. We need to find out an angle that is equivalent to 49 pi over 6. Now how do we do that? Well, the best mode of action is to compare this number, as we did in the previous example, to 2 pi. Is it bigger than 2 pi? Absolutely. This is much greater than 2 pi. So if it's bigger than 2 pi, that means it has to spin around more than once. How do we find out how many times it spins? Well, you're going to take 49 pi over 6 and divide it by 2 pi. As we did above, this number will reciprocate 49 pi over 6 times 1 over 2 pi. And we're going to multiply this out where we end up with 49 pi over 12 pi. What we're going to do next is cancel out these pi's. That leads to 1. And we have 49 divided by 12, which is equal to 4 spins and a little bit. Now that little bit we don't know precisely, and that's what we're going to find out next. What we're going to do now is take our number, our angle of 49 pi over 6, and we're going to subtract it by 8 pi as we did above, because we know it's going to spin 4 times, and each spin is 2 pi, so multiplying 2 pi by 4 gives us 8 pi. Subtracting these two, we end up with 1 pi over 6. 1 pi over 6. So this angle, 49 pi over 6, originally is the same thing as pi over 6. So let's draw that down in a Cartesian plane. This terminal arm right here will represent pi over 6. And this right here will represent a 90-degree angle, or pi over 2 angle. And this number right here, we know because we've memorized the right triangle, that should be pi over 3. So across pi over 3, we'll have the square root of 3. Across from pi over 6, we'll have 1, and the hypotenuse is always 2. So our final answer, sine of pi over 6. Well, sine is opposite over hypotenuse. Our opposite is 1, and our hypotenuse is 2. And given that all trigonometric functions in this quadrant are positive, this answer will remain positive, and that's it. So there you have it. That is how to find equivalent angles and evaluate angles using sine and the unit circle. Remember to memorize this special triangle and this special triangle when tackling these problems. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.